Okay, so let's start to do the visual script for the repo script. So I will open up a reference so that you can take a look of this one. And I will turn off the preview so that we will not be disturbed by the result of the reference. Okay, so let's get started. And for this script, the geometry is right here. And that's the key of our design. And to motivate our design, the most important thing is to import the song. So let's start with this part. So first things, let's go to Firefly and call out our song captures. That's the most important component we are going to use. And as far as you can see, there's two input points. The first one is about time period, and that's the one which we can define the period of recording the song. And the second one is about start and stop sound capture, and that's about the accuracy to capture the sound. So that's the thing you need to understand. So for the first one, for the time period, we can define probably we want to record our sound probably 0.5 seconds or maybe 1 second. It's up to you. So let's type in maybe 0.5, enter, and create a slider right here and connect this one to time. And you can, if you increase this one, which means every 1 second you will do the recording, but it will be not that precise at all. So for me, I will just stay in 0.5. It will be better for you guys. And then let's go to using the start and stop. For this one, the old version in the reference, we call this one timer, but actually for now it's not called timer anymore. In Rhino 7, it has been renamed as the trigger. So let's go to parameter right here, input, and find trigger right here. Okay, actually they are the same thing, but the name is different, and also we have to change this one into time. So basically for now, as far as you can see, 1 second they will do the accuracy is 1 second, and you can change this one right on your right mouse button to click, change the interval, and change this one to maybe 5 microseconds. It's up to you, you can change by yourself. And hold on your left mouse button to connect this one with the start and stop component input point. So basically for now we have finished. Okay. So let's create a panel so that we can see whether this one works or not. Right here, and click this panel, connect the value to here. So once you click start, it will start to record your song. And as far as you can see here is the change of the number of your song. Okay, so once we have this basic motivation, we have the song data. We can use this data to do something interesting. So first is, because the target of this project is to create multiple repos, so we need to create multiple circles to do that. So first thing, I will use in pop2D to generate multiple points. And if you remember, multiple 2D is right here inside vector sections and this icon. So now we have this one. And for pop2D, actually we need to create regions. So to define where you want to put the points. Yes. So in order to do that, actually you can just draw a rectangle. It's up to you. You can draw a rectangle right here and input the rectangle to Rhino Grasshopper. So let's go to parameter, circles, curve, and right click and choosing one curve, and you will, once you select, you will be import right here. So if the component turn into gray color. So connect this one to the region. So as far as I can see, now we have multiple points. Another one is that you can just create by inside Grasshopper. You can choose in primitives, and you can choose in different shape you want. And for this time, I'm going to use in polygon. And for polygon, you can just choose in For plane, you don't have to define because the default plane you will put on the XY plane. And for the radius, you can change the radius by yourself. So actually, I would like to change right here. And also, we can define the radius of this polygons. So let's double click, maybe type in 10. Let's enter and connect this one to here. Radius 10. And for the segment, for now is 6. I don't just want a 4. So let's double Control C and Control V, copy this slider, change this one to 4, and connect right here. But it's still too small, so probably we have to change the maximum number of the radius. So let's right click on the slider, go to values, and define the maximum, maybe to 1000, and commit change. So now you can enlarge this one. And for now it has been rotated in the 45 degree, and if you don't like that, actually we can just rotate, double click on rotate, and you can put in your geometry right here and type in your number right here. But for now, the default setting of the degree system is pi secant system. So it's not the degree system, the 360 degree system we know. It's more about pi, 2 pi, things like that. So we have to change this one into the degree system so that you can connect this one with this one. So let's type in maybe 45 degree and turn off the preview right here and connect this one to the pop 2D. So that's the result you get. Okay, so the polygon to generate the polygon system, and you can define the size of the polygon by yourself, and also you can change the segment by yourself. And because for this one it will depend on the radius system, the pi system, so we need to change. If you want to rotate this one into the horizontal or vertical direction, we need to put a rotate component right here and change this one into degree system so that you will finish. Okay, so now we have the pop2D and we don't need to import any reference data into our scripting. So I would say it would be way more better because once you open up a new file, you don't have to create anything inside Rhinosys. You just do everything inside Grasshopper, and it will be fine. So once we finish this one, let's take a look about the pop2D. Here is the reference. So the count of number is the number of the points. So you can define how many points you want to create. And for this time, I would say maybe just 10 would be quite enough. So I will type in, double click on the slider and type in 10. Connect this one to the number. And if you want more, for sure you can create more, but I would say maybe just 10 will be fine. Okay. And then, actually we don't need to see the geometry, so I will turn off the preview. I just want to see the points. And the second one is about the seed. It's about the randomness of your point. So if you increase the number right here, it will become more chaotic. But if you don't want to do that, you can just stay in 1, or it will look like this. But if you want the position of the point will change based on your value, actually we can just using a little trick right here. So let's copy this one again, Control C and Control V for copying the slider, and type in this one as 1. And I want to use the number right here to change the randomness of the positions of the points. How can we do that? Let's use in math and using multiplications, connect this one and this one. But for because the result will be really huge, but so actually I would say maybe make this one smaller. Let's change the value. Maybe just type in 0.1, commit change. And for now it's integer, so let's change the slide typer into floating point and change this one to 0.1. And then connect this one to C. So as far as you can see, now the position of the points will change based on the value. But if you don't like this one, you can just stay into the one still number when both of them could work. Okay. So now since we have the pop 2D, we have the points, the next part is about the radius of the circle. And because I want to create a multiple circle in one center point, so we need to use a recorder, data recorder. That's the and so that we can record data, not just generate one, but we can record maybe 10 data at one time. So let's double click on empty space and find data recorder. Data recorder right here. And you can connect this one right here. And also you can change the record limitations, and for now it's 10. And if you want more, you can create more, but I will stay as 10. Okay? And for the data recorder, so now we can record the data, and every time we'll record 10 data. And so for next time, we are going to using the data we record to generate series of number. So in order to generate series of number, we are going to use in this component, which named series. Series will generate a bunch of numbers, random actually not random number. You can define where to start and where to stop. So let's go to type in series right here. Okay, and for series, actually there's 3 components right here: the start point, start number, and the number of the state. Which means if you start the number from 0 and if the number of the state is 1, so basically it will just generate one number. And if you generate more, it will generate sorry, not this one. The count is the number which you generate. So the start number, if you start the number from from 0, and the number of the state is from 1, and the count is from 10, so basically it will generate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers for you. So you can define these things. So but for me, for the start number, I would just stay in 0, so I will not connect anything right here. But for the number of steps, actually I hope this one could be more random. So let's use the old same trick again. Let's go to here, copy the multiplications, and Ctrl C, Ctrl V, connect the recording right here to the A. And for the B section, you can just define one number, because for now it's too large. Every time our value is probably 600, 800, and if I do that, the circle will be super large. So rather than doing that, I prefer maybe we can just adjust to the number into 0.1. It will be better. Ctrl C and Ctrl V right here. Okay, so it will be much more smaller. And then let's connect this one to state. So for now, the number we generate will be based on the value of our song, and also every time it will have a random state. So the size of the multiple circle will be different. So for the count, I would say maybe just stay in 10. It will be fine. But if you want to define, you still can give this one a slider. So let's type in. Will be one more slider, Ctrl C and Ctrl V for copy, connect to here. So for now we can generate 10 numbers right here. So the final thing is, let's combine these two things together. I will make this one become one group, Ctrl G for grouping, and this one is another group, and this one is another group. Let's move this one over this thing here. Okay, so for now, let's using the data we have to generate a circle. Circle is very simple, just type in circle right here. And in order to define the circle, we need the point, and we also need the radius. So for now, we can generate multiple points right here. Okay, that's the result we can create. Or maybe I would say let's make this one smaller. Okay, and we don't need that much circles, maybe just 3. Okay, and for now, because it was still working, so I would turn off that one. Enable, so enable this one here, and also I will delete them so it will save more time. Okay. Just click. Now, because we have generated too many, I would say maybe too many points and too many circles, so it was a little bit lagging. So let's change it a little bit and waiting for response. Okay, now it has respond. So sometimes we need to do some adjustment. For example, because my voice it will raise, so sometimes the circle becomes super large. So we need to change the size right here. So decrease the steps. Maybe into 0.5 will be fine. And also for the record data, it used to be 10, but if we use 10, maybe it's too large. So it will depend on the power of your laptop. You have to change the number right here, maybe 3 or maybe 4. It's up to you. Okay, so I will just stay here. So for now we have the circle right here, right? So the last part is about to coloring all this circle. So how can we do that? So right here is the most complicated part. So in order to create to coloring that part, we have to explain a little bit about the function of gradient. Usually inside Render Grasshopper, because it's not for rendering. Render Grasshopper, all the color and texture inside Grasshopper is just for preview. You cannot use them in real render or in real model. It's just for previewing. So we need to create a custom preview so that the color inside Grasshopper will show up on Rhinoceros. So that's the first thing. And the second thing is that for the custom preview, first thing there's one geometry input, which means that's the geometry you want to do the coloring, and another one is about material. And for the material, you can choose in gradient color and another rendering tool under display mode inside Render Grasshopper. And this time we are going to using gradient color for rendering. So let's code out these things to get first. Custom preview. This one, this component. And another one is about the gradient, and for flatten we will explain later. Let's code out the gradient color. Okay, so for the gradient, for the geometry, there's no doubt for sure it will be the circle. So let's import the circle right here, and we don't need that one anymore, but we can turn off them later. Oh, let's turn off this one for now. Okay. So let's turn off that one for now. So as far as you can see, once you connect this one, the custom preview will give you the default color right here. It's pink color. But for now, I want to using the gradient color to control the material. And you can define the gradient color by yourself. You can set as before or using the default preset color setting right here. And this time maybe I will choose in this one the red, yellow, and blue color. Okay. And let's connect this one to here. For now it doesn't work. Why is that? Because the data right here actually there's no definition for these two things. So actually for now there's still no data right here. And so we need to define the L1 and L0 and L1 data, and also this parameter for input data right here. And what's that mean? It's a little bit complicated, to be honestly, but I will explain right here. So because we hope the color will be changed based on the size of the circle. For the size, if the size of the circle is more bigger, maybe the color will be more close to here, more to the deep blue. And if the color, sorry, and if the size of the circle is more small, it will be more close to the light blue. So in order to do that, we have to measure the size of the circle and then extract the data of the extract the maximum size of the circle and the minimum size of the circle and import this data to here. So it will generate a series of the color between all different sizes. So for example, the maximum circle will be right here, the minimum size of the circle will be right here, and the in-between size of the circle will be right here. So that's the logic of the rendering part. So in order to do that, first thing is we need to make the circle become, actually we don't have to do that, we can just import area. We have to type in an area component, and for the area component we can measure the size of the circle. Okay, and then there is multiple data right here. For example, there's a bunch of data inside this component, and let's take a look using the panel to see that. As far as you can see, there are multiple data, and each size, basically this is the 0.1, 0.2, which have already generated 10 points right here, if you remember. Sorry, not here, right here, 10 points right here. So, and every point they have multiple data inside. So in order to do it, in order to import all these data into just one level, all right here. If you just import right here, basically they will arrange all these data in different zones, different groups. So in order to put them in the same level, I'm going to using another component which named flatten right here. And for flatten, it will collapse all the level to level 1, so you won't have this multiple group anymore. So let's click here, and also we can use in this one data tree. Let's call this one data tree. Data pad. Okay, not this one. Data tree right here. Alright, let's do that later, okay? It doesn't matter. Let's use this one first. So let's flatten everything together inside the flatten data. So for now, it will become just one group. Let's Control C and Control V, and we can also show right here. There's no group anymore. Okay, so let's delete this one. And for the flatten one, we need to extract the maximum number and the minimum number, so we can using them as an anchor to count where is the maxima, where is the minima, and where are all the other in-between numbers. So let's type in bound right here. Actually, you can find under the mask and bound right here. So let's connect here to the bound, so you can define the maximum number and minimum number. And then it will become a new digital domain, which was composed by the max size of the radius and the minimum size of the radius. So for now, let's use this one to connect with I want to extract the maximum number and the minimum number. So that's using the domain right here. Let's find that one. The domain, where is that? The construct domain right here. So with this one, we connect to the bound right here. We can extract the maximum number and the minimum number right here. So let's connect the maxima to the start point to L0 and the end number to L1. And then for the only rest, I'm going to import the number right here. So for now, as far as you can see, the maxima it will be blue. The minima, it will be more close to red color. So basically for now, we have already finished the parameter, the entire video script. So basically for this one, you can we will use this logic very often. So you can just keep these parts, and next time you don't have to reconnect them anymore. I will make I'm going to do some refresh and also some organization. So let's group the final part. This is more about rendering, and this is to define the positions of the center points, and this is to define the size of the circle. Okay, and here is the start point. You can stop to recording for now, and also, and if you want to keep continuing, just click here. Okay, right. So that's about the video script, but this time I would say this example is a little bit different because for this one I will using let's say I will change the size. I would define the region of the points by the manually draw curve. But this time I just do them all of them inside Rhino Grasshopper. And also actually for the size of the circle you can define we can define based on the based on inside Rhino Grasshopper. So we can do that as well. But I would say maybe we can just stay right here, and if you want to refine this script, we can do them. You can try to do that by yourself, but for now, I will just stay right here. So that's the first video script we have ever made. Please try to connect all this data by yourself, and next time we will try to do something different. Okay, see you next time.